All right. Bet you can't see that too well. Let's see if we can fix that for you all. Today, we're going to be studying 3-6 compound inequalities. Our SWABAT is to write, solve, and graph linear inequalities. Vocabulary for today, beautiful people, is compound inequality. Interesting. Compound, you've heard the word before, like compound sentence, compound words like desktop or watermelon. Today we're going to be talking about compound inequalities. Compound inequalities are inequalities that are combined or joined by the word and or by the word or. We're going to talk about both of those scenarios. So let's start with and. An and one will have two values, let's call them A and B, and then one might be open, one might be closed, and it would be shaded in the middle. And this would look like A less than X less than or equal to B. If you look at these separately, this is like saying X is greater than A because I'm pointing to the A between the X and the A, and then and it's like saying X is less than or equal to B. Here's how that works. At B, it's closed because it's equal to, and it's going inward that way. At A, it's open because it's not equal to, and it's going that way. So the variable X is between the value A and B. For and statements, you're always going to shade in the middle. Always, always, always. For or statements, you keep them separate. So I might say X is less than A or X is greater than or equal to B. So I would have a value A, an open circle, and it's shading to the left. And at B, I'm going to have a close because it's equal to. And I would shade to the right because that's where the arrow is pointing. It's greater than B, less than A. So those are the two new ones. For or, kind of a little bit more intuitive because you're going in two different directions. You got this or that, this or that. And then for and, if your variable is in the middle, you're going to shade in the middle. So think about your variable being between two values. Your variable is between, BTWN, two values, between two values. Okay, let's give one a shot, shall we? Translate the verbal phrase into an inequality, then graph the inequality. So all real numbers, let's use a variable for that, X, that are less than 4. Remember for less than, our arrow should point to the left because everything to the left is less than. And you're welcome for that. X is also going to be greater than 0. So let's try to combine these. When I combine and statements, I'm going to have my two values. So I have 0 and 4, and I have X in the middle of them. Now how about your arrows? Well, between the X and the 4, it's pointing to the X. Between the X and the 0, it's pointing to the 0, Here's how I know I'm right. Two criteria. Criteria number 1, your arrows should be pointing to the smaller number. 0 is smaller. Criteria number 2, they should be going in the same direction. Both going in the same direction. Now, another solution that you could have also written would be this one, where your arrows are still pointing to the smaller number, which is 0, and they're both going in the same direction. Either one is fine. I will typically, though, go with this one, only because it's already in order from left to right, from the smallest number to the biggest number. Okay, so let's graph this really quickly. This might be 0, 1, 2, 3, 4. I have open at 0, and my arrow was pointing to the right, so I'm going to go this way. And I have open at 4, and this arrow is going to the left. So the point where they intersect, or the area where they intersect, is right there. This is an and statement. Number 2, all real numbers, X, that are greater than 4, or the value, all real numbers of X that are less than -2. Just remember, like, they don't say all the numbers again, so you're just going to put the x part for that part. Okay, let's graph. Here's -2. I have an open circle and I'm going to the left. -2, -1, 0, 1, 2, 3, 4. I'm only labeling the key points here. I'm not labeling every single point. And then this one is going to the right as the arrow is suggesting, to the right. Bam. There you go. That's graphing them and writing them. Let's try some applications here, minor applications. Your veterinarian, your vet tells you that in order for your dog to be at an unhealthy weight, he must be fewer than, that means less than, 70 pounds or more than, that's another keyword, so greater than 80 pounds. So his weight, let's use W, could be fewer than, so less than 70 pounds, he's unhealthy, or if his weight is greater than 80 pounds, he's unhealthy. Those are, those are your two different possibilities. Fewer than means it's just less than, it's not equal to. He can be 70 pounds and he's fine. He could be 80 pounds and he's fine. But if he's less than 70 or bigger than 80, we have a problem. So I'm going to start at 70, 71, 2, 3, 4, 75, 76, 7, 8, 79, and 80. Open circle, sorry, at 70. Notice here my shading is still on the line. I just made it a little darker to make sure you can see it. At 80 is open, and it's going to the right. So if my dog, it weighs anything in between here or here, that's an unhealthy dog. I'm not feeding him too much, or I'm feeding him way too much. One of the two options. Number 4. The cost of a box of stationery ranges from $2 to $3. So it's going to be anywhere between $2 and $3. Between. Dun, 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 dun. That means it's going to be an and statement. It's between. Instead of A and B, it's between 2 and 3. Well, what's between 2 and 3? The cost, we'll call it C, of stationery. What about those arrows, Miss Fitzgerald? Well, they need to point to the smaller number, so that would be to the 2, and they have to be in the same direction. Now we have to question ourselves, or ask ourselves, can these be equal to, or are they strictly greater than and less than? Well, it says it's between $2 and $3. So, well, it says it ranges from $2 to $3. That means it's equal to $2 because it could be $2, or it could be up to $3. But that's it. Let's graph this. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to 3 and make this like $2.50, just so I have a little bit of space in between those. So it's closed at 2 and it's closed at 3, and the cost is anywhere between $2 and $3 inclusively. There we go. Beautiful. Okay, this number 5, it says to write an inequality for the graph. This is an OR statement because they're going in two separate directions. And this is x is less than or equal to, because it's closed circle, -1, or x is greater than, for this area to the right, greater than 4. There we go. Now, I kind of like going from the graph to and statements. Here's why. Here's my first boundary at -3. Here's my second boundary at 5. And then I have my variable always in the middle. Now let's just talk about the arrows. Which one's smaller? -3. Very good. And they're going in the same directions. Now, this one's open, so that's great. This one's closed, though, so I'm going to add the equal to sign there. Bueno! Alright, my pretties, let's go on. That was from Wizard of Oz. I'll see you, my pretties. Solve the inequality, graph your solution. Now, let's, for just one moment, take your thumb or something, or a pencil. Bam, pencil. Now, if this was not there, what would I do first in order to solve this? If you said distribute the 3, you are correct. I'll distribute the 3 to the n and get 3n, and the 3 to the 3 and get +9. But I'm going to rewrite everything else, though. Now, again, with my handy dandy pencil, I'm going to cover this and say, okay, well, now what would I do? Well, if that wasn't there, Misfits, I would subtract 9. The only thing is, typically you would say, oh, I'm going to subtract 9 on both sides. But now you have 3 sides, so you just hit it, boom, boom, and boom. Only new thing, just one extra time. So I have negative 15 is less than 3n and less than 12. Now I'm going to divide everything by 3. Because if this wasn't here, I would just say, oh, divide by 3. I'm going to do that. Divide, divide, divide. So negative 5 is less than n and less than 4. Check your arrows. They're going in the same direction. Great. And they're pointing to the smaller number. Also great. So I'll start over here at negative 5, 4, 3, 2, 1, 0, 1, 2, 3, 4. Glad I made it. Open for both of them because neither of them are equal to. And then I'm going to shade in the middle. Notice, if you don't have a highlighter, you're not in a bad situation. You just need to make sure that I can see where you have shaded, and then we're all good. Ooh, it's gone, it's gone, it's gone, it's gone, it's gone. And we're back. Light again. There you go. Let's try number 6, our last example. Solve the inequality in graph one more time. Now, or, to be honest, I do prefer the and, even though it looks kind of funky, because for or, you basically have 2 problems to do. Starting with this one, negative 2h minus 7 is greater than h plus 5. I want to get my variables together, so I'm going to subtract h on both sides. And I have negative 3h minus 7 is greater than 5. I'll add 7. Negative 3h is greater than 12. Ooh, h, not x, misfits. Divide by negative 3. These cancel out. H is, stop the press, less than negative 4. Why? Because I divided by negative. Remember that whenever you multiply or divide by a negative, gotta flip the arrow. It's gotta happen. Okay, now a little more work. 1 over 4 times h plus 8 is greater than or equal to 9. This is a friendly fraction. I kind of like it, so I'm going to distribute it and have 1/4 h. And then 1/4 over 8 just means I need to divide by 4 because there's just a 1 on top. So 8 divided by 4 plus 2 greater than or equal to 9. Minus 2. 1 over 4h is greater than or equal to 7. Now, to get rid of this 1/4, I'm going to multiply by 4. And I have h is greater than or equal to 28. And then I'm freaking out like, wait a minute, I got to go from negative 4 to 28 on a number line? Not a problem. Not for me anyways. Negative 4, I can go by 4s. So the next one would be 0. Then this would be 4. This would be 8. This would be 12. 16. What's 16 plus 4? 20. 24. 28. I just went by 4s. It's not a problem unless you make it a problem. So I'm going to make this one at 28 closed, and I'm going to shade to the right. And at negative 4, I have an open circle, and I am going to shade. I know you've been waiting for me to do this all lesson long. To the left, to the left, to the left, to the left. Yep, you're welcome. All right, beautiful people, that is it for this lesson. Thank you so much for joining me, and I'll catch you next time.